I am Xinghui and I'll be explaining my medical electronics assignment. This is what my circuit looks like. So for the first circuit, it is the dual low noise JFET op amp. So the TL072, it is used to amplify the input signal with all the different components like the 10k ohm resistors. So at this part where all the capacitors are used, these are actually all used to stabilize the voltage as well as decrease any noise that is around. And then at this part would be the band pass filter, which we use the formula ACL equals 1 plus R2 over R3, which gives us 1 plus 220k divided by 10k, which gives us the answer to 23. And then at the start of the circuit, this part before the capacitor actually blocks out any DC, and then this would be the voltage divider between the two different resistors, which reduces any voltages to a more usable value. And then at the end of the circuit would be the capacitor 10U, which allows any AC to pass through. So for the second circuit, which is in between the first and the third one, it is actually the closed loop inverting amplifier. So at this part between the R9 and the R10 is actually a level shifter. And then for this TL072, it will shift 180 degrees out of phase, and this part is the trimmer which would adjust our gain. So at this part, it would then be the fixed gain loop non-inverting amplifier. This is the result for my dual low noise JFET op amp. The max gain would be 22.5. So as seen in my result, the max gain is in between my 100 hertz and 500 hertz. So before 100 hertz, the results would slowly increase until 100 hertz, and after that, it would slowly start to decrease since it is higher than the max gain. So as seen here in my graph, the lower frequency would be 20 hertz and the higher frequency would be 1.1 kHz. So the bandwidth would be taking the higher frequency minusing the lower frequency, which gets me 1080 hertz. And this is after the 3 decibel line. So for the third circuit, it is called the Salem key second order low pass filter. So at this part where the capacitor 10N is at, it is the capacitor that is for feedback, which allows low frequency to pass through it. And then it would filter out any high frequencies. So at this part where there is R12 and R11, both 10K, is called the voltage divider, like the one similar at the first circuit. And this part at the capacitor 8, it filters out any of the DCs. This is my result for the circuit just now. And at 220 to 100 Hz, there is unity gain, which is normally 1 for gain. And above 500 Hz, there will be no unity gain. So after 500 Hz, the results would normally all decrease down. And for my graph, after the 3 decibel line, my cutoff frequency will be 900 hertz. So my bandwidth still be 900 hertz as there is no higher or lower frequency. And for the last circuit, the fourth one is called the audio amplifier stage. So LM386N is connected to resistors as well as capacitors to gain control as well as to filter out anything. So for this trimmer at the E part is a full amplitude, and then at the S and A part it would be zero amplitude. This is because audio amplifiers have the single supply mode, which drives all any current to the speakers. So this part, it would be the filtering of any high frequencies. And this is the end of my presentation. Thank you.